All right, hey calculus folks, coming back with a brand new video, Notes 4.1 Extrema on the interval. So we're actually starting a new unit, and this unit is based on one of the main big questions in calculus, because one of them is, can you find the equation of a tangent line? Another one is, can you find the area of the curve under a curve, which we haven't done yet. And another big question in calculus is, can you use calculus to more accurately graph equations? And so our whole unit is geared towards accurately graphing equations where you can actually tell where a graph curves up, where the max and mins are, where it curves down. So you can do all this stuff with calculus. So one of the first things we do is talk about extrema. And this section, 4.1, is all about extrema. And extrema is the maximum and minimum y values on a graph. So it's fancy for extremes, right? The highest and lowest points. The maximum and minimum y values on a graph or an interval. And this one's weird. It's easy to see the ones on a graph. You can see, is there a highest spot or not? Is there a lowest spot or not? On an interval, you're guaranteed there will be one max and one min. So the thing about intervals is they can be open, closed, or partially open. You don't need to say partially closed because that's the same as partially open. It's just kind of like glass half full, right? Versus glass half empty. So you got to decide what kind of person you are. Well, you could say the glass is always full. It just has air in the top half. So, you know. So that's a little philosophical, but let's actually take a look at this. If it's an open interval, it'll look like this, from A to B with parentheses. We already did this when we did intervals. If it's a closed interval, you'll see A to B with brackets. And partially open would be, you know, like this or like this. So there's your partially open ones. There's your closed, there's your open. Okay, so basically the intervals we've looked at before. So now let's analyze. We're going to analyze a function. Analyze a function. So we're going to take f of x equals x cubed minus 3x. So this is a cubic, and we're going to do a quick sketch of it. Okay. Ooh, nice. So it goes through 0, 0 for sure. When you're at 1 here, you're at negative 2 here. When you're at negative 1, you're at positive 2. And then if you put in a 2, you'll be up at 2, 2, 2. Because 2 cubed is 8, minus 6 is 2. Kind of the negative version of it over here. So basically you have this pretty typical cubic shape where it goes up and then down and up again. It goes forever up and forever down. So if I had if I asked you about an absolute minimum, so we often want to find an absolute max or min. So if I asked you for an absolute max or min on this whole graph, there is no absolute max or min. there is no highest y point because this goes on forever. And as soon as you think you picked the highest one, it goes on past it. As soon as you think you picked the lowest one, it goes on past it. But if I wanted the absolute max or min on an interval, that would be the highest or lowest y value on the interval. So how about instead of looking at the whole graph, we looked at this graph on the interval from 0 to 2, including the endpoint. See how it's a closed one? So basically what that's saying is we're gonna chop our graph right here to right here, right? And we are including the endpoint. So I'm going from here all the way down here to here. I'm not including the other stuff. So on here, you can look at all the points and say, okay, is there a very highest point? Is there a very lowest point? And you have to check a couple of spots. You have to check the endpoints. So if you look at this where it ends, it's the point 2, comma 2. And where it starts is -2, -2. Oh wait, I don't need to check over here. Gosh darn it. I'm checking from here to here. Scratch that. These are x values from 0 to 2. Man. Okay. So I'm going from here to here. So basically, if I look at this chunk of the graph, the very highest point is right up here. So this would be my absolute max. My very lowest point is down here. This is at 1, -2. That's my absolute min. Basically, the only places max and mins happen are where your graph changes direction from going down to up or at an endpoint. So extrema only occur at two places, either when the graph changes direction that was this point here where it goes from down to up, there's a min, or on an endpoint. Okay, so up here, that's an endpoint. It's not changing direction, but since I chopped my graph off from here to here, that's the absolute highest point. Okay, so those are the only places that you can have your absolute maxes and mins. Okay, so that brings up something else. A lot of times we're not concerned with an absolute max, but we're concerned with relative extrema. This is like the cousins and uncles of extrema because they're your relatives. Good times. Okay. These occur anytime a graph has a change in direction. Okay. Basically, you want to think hills and valleys. It's what you think of max and mins, but they don't actually have to be your highest point and lowest point. We'll write that. It does not have to be an absolute max or min. So for instance, if I looked at a weird graph like this, ooh, kind of looks like a fourth power or something. I'll draw this in. Okay, so this right here would be considered a relative min because the graph goes down and then back up. So for this chunk of the graph, it's the lowest point, but it's not your lowest point on the graph. So it's a relative min. This right here, where it goes from up to down, is a relative max. However, it's not your absolute max because see how your graph goes up forever? So that's not the highest point in your graph, but you would call it a max because it's like a hill. This one down here is actually both. This is a relative min and it's your absolute min. Because not only is it from down to up a relative min, but it's also your absolute min because it is the lowest point on your graph. There actually is no highest point on this graph. So you can have an absolute min and not have an absolute max. Okay, so let me stop this video here and then we'll do, well no, one more thing in here. One more term and then we'll do a different video with a couple example problems that are going to be like your homework, or an example problem, like your homework. So first, before we move on, we have stuff called absolute mins, absolute maxes. We have relative mins, relative maxes. Those are your hills and valleys. We have something else that's important, and it will be important this whole unit. So get this in your head. Critical numbers. We're always going to be talking about critical numbers. Sometimes we shorten it to CN because we get tired of writing critical numbers. We do it so often. Critical numbers are where the derivative is 0 or undefined. Those are critical numbers because that's where cool stuff happens. This is one place where extrema happen. Okay, so when we do our next problem in the other video, for an example problem, we're going to be looking for critical numbers because when the derivative is 0 or undefined, that's one place where extrema happen. The other places, they also can occur at endpoints like we saw earlier in this notes. Alright, so we'll come back and do an example problem.